Hello. 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 Hello.
Good morning. In discuss Madibin, what all we discussed yesterday? The thing is geomorphology. Under geomorphology, we dealt with plate tectonics, which is first day's topic, and different types of boundaries. After that, we discussed two things. One is endogenic forces, exogenic forces. In endogenic forces, sorry? Endogenic. I'm speaking about endogenic forces. Forces inside the Earth's surface, which generated inside the Earth's surface, whereas exogenic forces outside the Earth's surface. In endogenic forces, we have two major kinds. One is good catastrophe. What does diastrophism means? What is catastrophic means? Example for something which is slow. Something which happens slowly, and example for something which happens all of a sudden. Good. Sudden movements are earthquakes and volcanoes. Whereas slow movements are epirogenesis. In technically, we term it as epirogenesis. Whereas other one is orogenesis. Epirogenesis is nothing but continent building, whereas orogenesis is nothing but mountain building. This is the broad overview. After this, we dealt with exogenic forces. In that, we have discussed about weathering and erosion. Weathering comes in this only. And we have studied different agents and their landforms, such as running water, groundwater, glaciers, wind, waves we have not touched due to shortage of time. Till waves, till winds we have come. Okay. After this, we studied about something related to mountains. In this only, orogenesis, in that orogenesis, we studied different types of mountain. What are the major types of mountains? Yeah, fold and block mountains. Apart from those two, volcanic mountains. In mountains, we discussed fold, block, volcanic, and residue. After mountains, we dealt with plateaus. In plateaus, we have majorly how many types? Good. Two types. Which are those? Dissected plateau and volcanic plateau. Later, we studied about plains. In plains, we just discussed how our plains form due to erosion done by many of our river systems. After this, we have discussed erosional landforms and depositional landforms of various geomorphic agents. First one is running water. What are the erosional landform features formed by running water? Rills, gullies, valleys. After that? Rills, gully, valley. After that? After valleys. We have studied about meanders. Yeah. Those are all erosional landform feature. After meanders? Atolls, plunge pools. Depositional landforms of running water? Good. Channels. Right. After that, we discussed about underground landform features. Which are the underground landform features? Erosional and depositional. Erosional landform features of underground water. Good. Collapsings, caves. In depositional landforms, what we have studied? Deposition. Site and pillars. Okay. After that, we studied glaciers. What are the landform features formed by glaciers? Erosional? Sorry? Okay, circuit. Yeah. Then depositional? Good. Lateral moraines, medial moraines. After that? You missed one thing, jords, which is very much important. Jords are jords, valleys. These are U-shaped hanging valleys formed by the canon and the canons are different and jords are different. Jords are formed by glaciers. No, they are in glaciers. Jords are a type which are in glaciers. Okay. After that, we discussed about wind. What are the landforms formed by winds? In that? Good. After depositional landforms, we have bastions, sand dunes, and sites. Okay. That about geomorphology. In geomorphology, we are left with something which is very important, that is earthquakes and volcanoes. earthquakes and volcanoes. The question will come from this part, which will be covered in your advanced classes, because it needs minimum of 3 to 4 hours to deal with these two. Okay. Okay. In today's topic, we will cover rocks and climatology. Okay. This climatology is also a huge chapter which has enormous amount of potential to be asked in your questions, be it KPSC, UPSC or in the state exams. It has huge potential. Okay. Before moving to climatology, let us complete a small topic, which is rocks. What do you mean by rock? What is the meaning of rock? Good. Building blocks of lithosphere. Before moving to rock, let us understand something basic. Elements. Have you heard about this word, elements? In your high schools, I think everyone read about elements, periodic table. What do you mean by elements? Sorry?
Elements they are the study about the different types of gases like
Aluminium.
aluminum,
Not only about the gases. We include metals also, iron, copper. These are also metals which are a kind of elements. What does the basic definition of elements is? What is it?
basic material to make
Elements consist of a single kind of atom. A single kind of atom repeated. For example, if this is one atom of iron, this is also atom of iron. Such pure substances are called elements. Elements are nothing but this is group of single kind of atoms. In layman terms, these are similar atoms joined together. Example for elements, there are umpteen number of elements, say for about 118 elements in our periodic table. For simple understanding, let us take iron, copper, oxygen, hydrogen, zinc, name it anything, this comes under elements. After elements, we have one more thing which is very much basic, minerals. What do you mean by minerals? What does it is the purest form? It is purest form. Element is the purest form. What does minerals mean? Mixed. Yeah, exactly right. When two or more elements join together in a certain fashion with certain chemical composition, they form minerals. Example for minerals, any example? Any example for mineral? Hydrochloric acid. No, it is not a mineral. Something you read about, sorry? Gold. Gold is a mineral. Okay. Feldspar, which is a mineral formed by silicon plus oxygen. A mineral formed by silicon plus oxygen. This feldspar is found majority in the Earth's lithosphere. It forms about 50% of Earth's lithosphere. Apart from feldspar, we have hematite, magnetite, leaderite. Then famous one is bauxite, from which aluminium is extracted. These are the famous mineral substances. Minerals are nothing but it consists of two or more elements in certain fashion, in certain chemical composition and structure. After minerals, we have rocks. Then what does rock mean? Technically speaking, what does rocks mean?
basic rocks.
Yeah, it is layman understanding. These are building blocks of lithosphere. What is actually the definition of rocks? As we said, the elements of pure form and minerals are 2 to 3 elements combined together to form minerals. What does rock mean then?
Solid substances made with composition minerals.
Rocks are nothing but when two or more mineral blocks combine together to form rocks. Okay, this is the basic idea how rocks are formed. Rocks are formed by combination of two or more minerals. Okay, in today we will discuss about types of rocks. In types of rocks, we have three major kinds of rocks. Good. Okay, these are the three major kinds of rock. First, you understand, later you can take notes. First, what are igneous rocks? Igneous, the word igneous is derived from Latin, which means fire. Igneous. Igne means the fire. Do you know what this igneous rocks means? How they are formed? As you said, these three types, I'm asking you. That's it.
If we want something, the remaining objects.
It's called igneous rocks? No, not like that. Igneous rocks are formed from volcanoes. Directly from volcanoes, the molten magma will come out. This molten magma, when coming out, it will get solidified. It will get solidified due to lower temperature in the Earth's atmosphere. It will get solidified, forming a rock. These rocks are called igneous rocks. Have you got how igneous rocks are formed? When molten magma emitted from volcanoes, it gets cooled or solidified in the Earth's atmosphere, forming igneous rocks. This is as simple. Then there are majorly two types of igneous rocks. When the magma comes entirely out of the Earth's surface and solidifies, it is called extrinsic igneous rocks. It is called X when it is out from the Earth's surface. The surface which we can see, when magma solidifies on above the Earth's surface, it is called extrinsic rocks. When it is solidified below, say for example, imagine this is Earth. The volcanic eruption starts, it will release the magma here only and it will get solidified in this layer only before entering the Earth's atmosphere. Such types of rocks are called as intrinsic rocks. There are two kinds of igneous rocks. One is extrinsic, another one is intrinsic. Intrinsic is something which solidified inside the Earth's surface, say below the crust, whereas extrinsic is something which is solidified above the Earth's surface. Okay, then let us learn some of the examples. At least you should know one or two or three examples related to igneous rocks. As of now, the famous granite. Have you seen granite? Granite rocks. Where is granite used? For what purpose? Flooring. House flooring, we use granites. These granites are formed due to magma eruption or volcanic eruption. If they are cooled below the Earth's surface, they form intrinsic granites, whereas they cool above the Earth's surface, they form extrinsic granite. Okay. After that, we have sedimentary rocks. What does sedimentary rock mean? What does the word sedimentum? Sedimentum. We use the word sedimentum yesterday also, right? During running water depositional landforms, I use the word sediments. Sediments will deposited, sediments will get collected at one place. What does the word sediment means? No. Particles which who? Not only water. Yeah, exactly. These are smaller pieces of rocks. Small rocks, soil particles, which are weathered. These are known as sediments. Such sediments are formed. For example, when there is hill here, in hill we can see weathering process happening in the sides and slopes of the hill. Such weathering develops many of the rock particles known as sediments. Such sediments will run along the down the slope they will get compacted they will get compacted because when these sediment particles go down the hill, they will get deposited in the low-lying areas. In low-lying areas, the sediments will come deposit one on the other, forming a layer. They form the layer, right? The first coming one forms the bottom layer, whereas the next coming one is not working. Okay, the first coming materials forms the lower layer. After that, the next coming layer forms the upper layer. There they form the layers. Several years after that, they will get compacted due to pressure. When they fell one upon the another, they form a certain kind of pressure. Due to that pressure, they will get compacted. Okay. After compaction, there are several soil particles here and there. Soil particles and rain form a cement-like structure. Soil will form a cement-like structure, which is muddy, which acts as a cement and compact the rock particles to each other. This process is called cementation. When they get close to one another, forming a new form of rock with layers. These layers are formed in the sedimentary rocks. This process is known as lithification. What is this process called? Lithification. Such process is seen in sedimentary type of rocks. Okay. How are sedimentary rocks formed? By weathering process. After weathering, they undergo compaction and cementation. Okay. Sedimentary rocks has special features of lithification. Okay. Then we have metamorphic rock. What is metamorphism? Metamorphism. Anything morphic. Anywhere, if you find the term morphic, what does that state? Morphic mean? Morphism. Yesterday also in geomorphology, we dealt with the word morpho. No. Morpho is anything change in form. This morpho means change. Morpho means change in form. Okay. So yeah, what is metamorphic means change in form. In metamorphic rock, what happens? The particles of igneous rocks, particles, be it sedimentary rock, it undergoes weathering and forms many particles. These particles will undergo changes in pressure, volume, and temperature. When smaller particles of igneous rocks, sedimentary rocks, undergo changes in the form of pressure, volume, and temperature. Imagine extreme temperature. In extreme temperature, like a Thar Desert in Rajasthan, there we have many sand particles and soil particles, right? These sand and soil particle will go temperature change due to excess of temperature in such areas. That temperature change will change the entire atomic structure of the rocks present in igneous and sedimentary rocks, that change and form a new type of rock called metamorphic rock. Best example of metamorphic rock and easy to remember is marble. Have you seen white marble? White marble, Taj Mahal. Yeah, that marble is a kind of metamorphic rock. How are metamorphic rocks formed? Due to change in pressure, temperature, and volume. Anything which changes and form a new kind. It is a mixture. Whereas sedimentary rocks, it is just layering one above the other. The rock has not changed its form. It is just layered and compacted. Whereas in metamorphic rock, entire change in form, entire change in chemical composition and arrangements happens. It forms a new kind of rock. Is this concept clear? All the three kinds. You just have to learn how they are formed and few examples. For PCPSI exams, they will give a list of 4 examples and they will ask which among the following is a metamorphic rock, which among the following is a sedimentary rock. You should know few examples to each. Do you have any doubts? Is the class going good? Are you getting? Vishwanath, are you getting what I'm telling you? Okay, take down elements. It is quite faster, I do agree, because of shortage of time. That's it. Elements. Element is a pure substance. Element is a pure substance made up of only one kind of atom. There are confirmed 118 elements in the periodic table. This number can be varied. When I'm doing class, some scientists have researched something and they have added an element. It's not an issue. As of now, 118 elements are there. It is actually variable. Example, take down any of the element example which you like. Be it iron, oxygen, silicon, aluminium, calcium, uranium, anything. After this, you have to know, after studying the elements, elemental composition of our crust you have to know. You agree? Crust is made up of several elements. Yeah. You have to learn about the composition, which among the elements which has highest amount in the Earth's crust. First one is our oxygen. You should know the chronology also. Later you can learn starting 4-1's composition, how much percentage they form in the crust. First one is abundant element found in our Earth crust is oxygen. Oxygen is very much abundant in our crust. Don't confuse this chronology with the elements present in the atmosphere. We are speaking about crust, specifically outermost layer of the Earth. We have studied the crust, right? Crust is majorly made up of which layer? Yeah. In the crust, we have abundance of oxygen. First one is oxygen. Next, after oxygen, we have silicon, iron, calcium, sodium, potassium, and magnesium. Okay. You should know this order. And also, for first starting 4-1, you should know the what we say percentage also. Percentage in the crust. First one is oxygen. The percentage of oxygen present in the earth crust is 46.6%. Next is silicon. Silicon is about 27.72%. Next one is aluminium, which is about 8.13%. Later, first four, you learn the percentage also. Later on, you just remember. After iron, we have calcium, sodium, potassium, and magnesium. Okay? Yeah.
We call it a silicon.
Yeah. Why it is not called as silicon and oxygen layer? Yeah, good question. Because the crust contains oxygen because it is nearer to the atmosphere. Okay, and in the down, what we call mantle portion also, we have some amount of oxygen, but oxygen being it 46%, after oxygen we have majority of silicon and aluminum. This oxygen in the crust portion is higher due to presence of atmosphere. That's it. Okay, this is higher, but it is not given in the name of the layer. Okay, this is higher. We accept this is higher, but in the composition of crust we study silicon and aluminum because these are second next highest. The crust contain oxygen majority due to nearness to the atmosphere. That's it. Just make a note of this. Elements present in the earth crust. Just take down the same order. Third one is first oxygen, second silicon, third aluminium, fourth iron, fifth calcium, sixth sodium, seventh potassium, last magnesium. For first four, you have to remember the percentage also. Oxygen, silicon, aluminium, okay, iron, good. Then minerals. You want the previous slide? Then minerals. Take down the definition of minerals. These are naturally occurring organic and inorganic substances. Naturally occurring organic and inorganic substances having an orderly atomic structure, and definite chemical composition, and physical properties. It also have defined physical properties and chemical composition. Next, minerals are composed of two or more elements. Minerals are composed of two or more elements. Example, feldspar. Example, feldspar. Okay. Sometimes minerals are composed of single element. Sometimes minerals are composed of single element. Example, your gold, silver. Just you just listen from now on. Later you can take whichever is important. There are at least 2,000 minerals found in the Earth's crust. Okay, these are explored. Unexplored minerals are many. At least we have known 2,000 different types of minerals. Among them, feldspar is the important mineral which composes of about 50% of the Earth's crust. Apart from feldspar, we have quartz made up of sand and granite, which is also used in radio and radar communications. Okay. Then we have something like physical properties of mineral, which is very important. As of now, you just listen, don't make notes of this. There are 10 different physical properties, which are very important. Among them, these 5 are very much necessary to know. First one is color. When a mineral is grounded, when a mineral is made into a powder-like structure, it gives different color. In color, we have 2 types. One is a mineral color. For example, in the previous slide, see, this is feldspar. Which color it is appearing? Brown. Has a little bit of orangish brown color it is looking. Whereas quartz, it is like transparent crystal. Quartz is like a transparent crystal, whereas mica, which color it is giving? Yeah, it is a little bit gray, creamy gray to white color. Amphibole is like ash black. Okay, this is majorly the color, how they appear externally. Whereas in color we have something like streak. Streak is nothing but a ground powder of mineral. Which color it will give? It is not streak. If you are from science background, you have done this experiment in your labs. In chemistry labs, we are given some streak powders. We have to identify which mineral is that. Okay, in color we have 2 types. One is color, external color. For example, feldspar has the color of orange brown color. Okay, in streak is the color of mineral powder. The color of mineral and the streak color may differ. For example, if you ground this feldspar, it may give you white streak. It may give you white streak because the orange here is very low. The orange color appearing here is very less. When it is grounded to smaller particles, it may be white or it may be cream color. Then the color of the streak will changes. Then luster. Luster, what do you mean by luster? Something which is shiny. Some metals which are shiny, some minerals are also shiny, which is nothing but the way light reflected from the surface is called as luster. In luster, we have many types like metallic luster. For example, your gold, silver have metallic lusters. Glossy luster, for example, our quartz have something like glossy luster. Then we have hardness. Hardness is something that is resistant to scratch. For example, if this is a metal, if I want to scratch this, if I have scratched this with using a hammer, if it is resistant to that scratch, it is called as high in hardness. That is given the scale 1 to 10. Hardness has the scale of 1 to 10. 1 is something which will easily get scratched. For example, in this metal, identify which may be more vulnerable to scratch. Which may be more vulnerable. If you hit it by an hammer, which will get broken faster? Quartz. By looking, we can say quartz. Okay. In that, you have to know the extreme conditions. Talc is very much vulnerable to your scratching. Talc is nothing but the powder which we use, the face powders. These are nothing but talc. Okay, talcs are very vulnerable for scratching. After that, the highest one, which is very much resistant to scratching, is diamond. Diamond has the scale of 10. This 1 to 10 scale you should know for some minerals. So in that, the 2 extremes you should know. Talc with 1 and diamond with 10. Then cleavage. Cleavage is something like, imagine this mica. If I will break here, if I will break this mica here, it will form two parts. If this surface is smooth, if the breakage line, the surface near the break line is smooth, that is known as smooth cleavage. Cleavage is something which we found after breaking a certain mineral. This cleavage also in mica, we can see mica can be broken down into a thin sheets. In some minerals, this cannot happen. The cleavage is not smooth in some minerals, whereas in some minerals, the cleavage is very smooth and we can form thin sheets. These are malleable. After that, we have rocks. Take down the rocks. Definition of rock. Rocks are naturally occurring substance made up of one or more minerals They are building blocks of Earth's crust. They are building blocks of Earth's crust. The scientific study of rocks is called as petrology. This can be a Group C exam question. What is petrology? The scientific study of rocks. Yeah. Then take the types of rocks. First one, igneous rocks. Types of rocks. First one, igneous rocks. Okay. These igneous means in Latin, it means fire. Igneous in Latin means fire. Igneous rocks are formed by solidification of molten magma. These rocks are formed by solidification of molten magma. The other names for this rock is primary rock because it is formed majorly from Earth's asthenosphere. Primary rocks because these are the basis for other two kinds of rock. It is called as primary rock or parent rock. Examples, take down these four examples: granite, gabbro, pegmatite, basalt. Okay. You should learn all the four examples. Any one can be your option. Then types of igneous rocks. Types of igneous rocks. intrusive and extrusive. In this image, they have given clearly, say, if magma coming out of the earth crust and solidified on the earth's crust, it is called as extrusive. When it is solidifying here, the magma entered the sideways and it solidified below earth's crust, it is known as intrusive or intrusive igneous rocks. Take down one word for intrusive, formed inside the earth. Formed inside the earth. When they are formed inside the earth, the granules, the magma granules will be larger in size. They have large granules which are more visible. Visible mineral grains with large crystals. They have large crystals and visible mineral grains. Example, granite. In ground flooring and all, you will observe the granite stone has something like black lines, something like white dots. We'll see, no, in the flooring. This granite has some visible mineral grains. Then extrusive rocks. Second major type is extrusive rock. These are formed on the Earth's surface from lava. These are formed on the Earth's surface from lava. What happened? Do you have UPS supply for this? UPS. Extrusive rocks, these are formed on the Earth's surface. They have small or no visible crystals. They do not have any visible crystals. They are smooth. They are smooth. Example, basalt rock. Example for this is basalt rock. Then sedimentary rock. Second important type of rock is sedimentary rocks. It is derived from Latin word sedimentum, which means settling. As explained earlier, sedimentum. It is derived from Latin word called as sedimentum. Sedimentum. Sir, will the fan work? Will the fan work? Is derived from Latin word sedimentum, which is nothing but settling. These rocks are formed. Next sentence. These rocks are formed when all three types of rocks undergoes weathering. All three, any type, be it sedimentum, be it igneous rocks or metamorphic rock. Any rock which undergoes weathering. Yeah, even metamorphic rock can undergo metamorphism. It can change its temperature, pressure, and it will undergo metamorphism. Any three kinds. First one is igneous rock, is the only rock which is a parental material, which is formed from the Earth's magma. The other kind of rock, be it sedimentary rock, metamorphic rock, this can be formed from igneous rock, metamorphic rock, or the sedimentary rock itself. How? Because even sedimentary rocks undergoes weathering. They will undergo weathering and form small rocks. Even metamorphic rock also similar phenomena. Metamorphic rock like marble. Marble can also undergo weathering and change its structure. Similarly, metamorphic rocks, for example, marble. Marble can change its temperature, pressure, and form combination with other rocks, be it igneous rocks, be it sedimentary rocks, form combination, and it will form a new type of rock with change in color, structure, and its composition. Okay. Sedimentary rocks are formed when all three kinds of rocks undergo weathering. To form small fragments. To form small fragments. These fragments through compaction, turns into rock. Through compaction, they will turn into rock. These rocks are called as, this process is called as lithification. This is very important term. In several Group C exams, they have asked lithification is a process found in which among the following? It is in igneous, sedimentary, or metamorphic rocks. We also see number of layers in the sedimentary rocks because of their compaction, difference in time of getting compacted. We see number of layers of varying size in sedimentary rocks. Now, just see, this is one kind, first layer of sedimentary rock. After this first layer, there are several dead and decayed plants and animals deposited. Okay. After this, there is another layer of sedimentation. There may be some plants, animals, dead and decaying composition may be added. Then sedimentum. In sedimentary microphone. Okay. Okay. In sedimentary kinds of rock, we will find something which is buried inside. These are called as fossils. These fossils cannot be seen in igneous rock. Can we see in igneous rocks? No, the igneous rocks directly come from Earth's interior, whereas in sedimentary rocks, we can see fossils deposition. Okay, take down that. Fossils can be seen in the layers of sedimentary rocks. Layers of sedimentary rocks. Examples for sedimentary rocks. Just learn this. Sedimentary rocks has something in the end like stone, limestone, sandstone. Example for sedimentary rocks: limestone, sandstone, chalk, gypsum, coal, conglomerate. Coal, conglomerate. Clear? Okay. Now, this is the process which I explained before also. Just look at the image. These are small fragments of rocks which are get eroded and transported to some other places. For example, low-lying areas. After transportation, they will get deposited one upon the another, forming a layer. After deposition, they will get compacted. The release of moisture will get evaporated. They will get compacted due to pressure from upper layers. They will get compacted to one another. After that, we will have cementation. This is nothing but gluing of particles. Similar like your gum, the soil and water molecules acts as glue and the compacted layer will settle forever. that will form sedimentary rock. This is the newly formed sedimentary rock where we can find layers like dark brown, light brown. This is layers, and we have something like this brown dots. These are nothing but fossils. Fossils deposited in the layers. Okay, clear? Then we have metamorphic rocks. Take down metamorphic rocks. Third major type of rock, metamorphic rock. Metamorphism means change of form. Metamorphism, change of form. These are changed forms of igneous, sedimentary rock when subjected to rocks when subjected to extreme high temperature, when subjected to extreme high temperature and pressure, extreme high temperature and pressure, they undergo high temperature and pressure, they undergo metamorphism. Okay. In metamorphism, you should know the definition of metamorphism also. What is metamorphism? Metamorphism is nothing but the process in which already consolidated, first formed rock will undergo recrystallization and reorganization. Before formed rocks are igneous and sedimentary rocks. These will undergo recrystallization. They will change its crystalline structure and they will change its chemical composition. When they undergo recrystallization and reorganization, it is called as metamorphism. Take down, metamorphism is a process. Metamorphism is a process by which already consolidated rocks undergo recrystallization and reorganization. Now just think, we have seen layer formation in the sedimentary rocks. Can we see similar kinds of layer in metamorphic rocks? We have seen layers in sedimentary rocks. We agree with that. Can we see similar lines or lineation in metamorphic rocks? Yes, we can see, because the temperature at a time the whole stone will not get formed. The temperature will change. These are known for its foliation or lineation. This is nothing but layer structures. In this photo you can see. Metamorphic rocks have foliation or lineation. Next point, metamorphic rocks have foliations or lineations. Examples for metamorphic rocks: marble. Take down like this. You should know these also. In some exams, they will give match the following. Limestone. Limestone is a type of which kind of rock? Limestone is a type of stone. Limestone is a type of, just read your book, second one, sedimentary rocks. In that example, we have taken limestone. That limestone will change its temperature, pressure and form what? Marble. Just take down like this. Limestone forms marble. In above marble, you just mention this as metamorphic rocks. metamorphic rocks. Limestone will change into marble. Whereas shale will turn into slate. Slate is an example of metamorphic rock. Shale is the parent material. Shale is a sedimentary rock. Okay. Shale is a type of. Huh?
Shale is a stone.
Yeah. These are also rocks, but these are from igneous or sedimentary rocks. Okay. Shale stone. Shale stone is a stone, kind of stone. It will turn into slate. Shale stone turning into slate. Slate is an example of metamorphic. Then granite. Granite is which kind of rock? Yeah. Granite will change its form and form a new metamorphic rock known as gneiss. Granite forming gneiss. This. Shale into slate, whereas granite into gneiss. Fourth one, sandstone into quartzite. Sandstone into quartzite. Clear? This completes your rocks. Then just know few things. Rock formation is a cyclical process. Okay, rocks are used for various purposes like cement, writing chalk, fire. These are okay. Then we have rock cycle. Just understand how rock cycle happens. This is the magma. Where does magma originated? Yeah. From mantle portion, upper mantle asthenosphere is a rich source of magma. From magma, we will get which type of rock? Igneous rock. When igneous rocks undergo weathering, it will form which kind of rocks? Sedimentary rocks. If igneous rocks undergo change in temperature, pressure change, what will it form? Temperature changes. Igneous rock undergoing change in temperature and pressure. What? It will form metamorphic rock. When sedimentary rocks change its temperature and pressure, it will form metamorphic rock. When metamorphic rock undergo weathering, it will form sedimentary rocks. This is known as rock cycle. All the three kinds of rocks will go in a circular fashion. Okay. If these metamorphic rocks, for example, here volcano is occurring. We have some metamorphic rocks here. If this metamorphic rock changes its temperature, pressure due to high heat magma, it will form a new kind of rock again. Okay. This rock cycle moves in a cyclical fashion with melting, cooling, sedimentation happening one after the another. Okay. This completes your rock chapter. Okay. Solve few questions. These are very much easier.
Oxygen.
Yeah, which is most prolific is oxygen. If they asked about composition layers, crust and given as silicon aluminum, that will be right. Okay. Now for this oxygen. Second one you answer, Vishwanath. Okay. The scientific study of rocks that deals with composition, texture, structure, their occurrence, distribution, and their origin in relation to physiochemical condition is geology, geomorphology, lithology, and petrology. Then you answer. Which of the following types of rocks are formed by lithification process? Sedimentary rocks. Marble is an example of good metamorphic rock.
Oxygen.
Oxbow is a type of what is oxbow? Oxbow is a type of landform formed by no.
Meanders.
Good. A landform formed by running water, especially meanders. Okay. Okay. Let's take break of 10 minutes. Then we will start with climatology. Off again. On my 2 minutes. ಸರ್ ಎರಡಕ್ಕೂ PDF ಶೇರ್ ಮಾಡಿದ್ವಿ ಎರಡು
ಕ್ಲಿಕ್ ಮಾಡಿದ್ರೆ
ಹಾ
ಎರಡು ಸ್ಕ್ರೋಲ್ ಮಾಡಿ
ಇಂಪೋರ್ಟ್ ಮಾಡ್ತಾರೆ
ಅಲ್ಲ ಇಂಪೋರ್ಟ್ ಹಾಕ್ಬಿಟ್ಟು
ಇಂಪೋರ್ಟ್ ನೆಕ್ಸ್ಟ್ ಸ್ಲೈಡ್
ಕ್ಲಿಕ್ ಮಾಡಿ ಫುಲ್ ಕೆಳಗಡೆ ಸ್ಕ್ರೋಲ್ ಮಾಡಿ ದಟ್ ಸಿಂಪಲ್ ಅಂತ ಇಂಪೋರ್ಟ್
ಚೆಕ್ ಮಾಡ್ತೀವಿ The new topic, very technical topic, very question area. Mark it as important topic, okay? I have just 1 hour 45 minutes to complete this topic, which is highly impossible to cover. You just make a list of topics which I will give. Certain topics I will cover today. In few topics you will get in your advanced courses, okay? In climatology, what do you mean by climate? What is the meaning of climate? Good. Long term. How much long term?
years.
Together, how many years? Sorry?
13.
Good. Exactly right. It is a long-term weather average of a larger area. It covers a larger kilometers of area for about long time duration. For example, 30 years or plus. Say, for example, Gulbarga or Kalaburagi has certain type of climate. Which type of climate does Kalaburagi have? Whether it is monsoonal type. Every Indian places in India are monsoonal type of climate. Apart from that, how is the climate here? Do you experience heat? Extreme heat compared to other parts of Karnataka, you will experience extreme heat. This heat persists. Your parents also experience the same heat. You also experiencing the same heat. Your children also experience the same heat. For example, like that, minimum of 30 years, we have same climatic condition. This is known as climate. Whereas weather, there is another term called weather. What does weather means? It is day-to-day changes. Day-to-day changes in temperature, pressure, rainfall, everything. Day-to-day changes. In the morning, if we get rain, for example, yesterday night, if it rains, it is a rainy day. That's it. That is known as weather. It may be a sunny day in the afternoon, rainy day in the evening, and early morning, you can get cold winter chills. Okay. In climate, we have many subtopics. First subtopic is your atmosphere. Atmosphere. What are we are dealing in atmosphere? Now, what is the atmosphere? What is atmosphere? Yeah. It is blanket of gases which surrounds the Earth's lithosphere. Above the lithosphere, we have atmosphere. Okay. In this atmosphere, we will understand the composition of atmosphere. What is its major composition and structure of atmosphere? What are the different layers? Composition and structure. There are different layers in the atmosphere. We are going to study that. Okay. After atmosphere, we have something called as insolation, which is nothing but where does the earth gets energy from? Sun. This energy coming from sun is known as incoming solar radiation, which is nothing but insolation. Incoming solar radiation is called as insolation. In that insolation, we will discuss about heat budget. Heat budget is a concept which covers how much amount of sun's energy is entering the earth, how much energy is exiting the earth. Okay. Does earth emits any form of energy? Yes or no? That's it. Just guess. Does earth emits any form of energy? No.
Radiations.
Yeah. Earth will get absorb some amount of energy from the sun. It will emit remaining. It is known as terrestrial radiation. It is known as terrestrial radiation. This all we will deal in heat budget concept. Okay. After that, in insulation, we have conduction, convection, and radiation. Three forms of energy generation: conduction, convection, and radiation. Okay. After dealing with insulation, we have a concept called as winds. What do you mean by winds? Winds. What does wind mean?
Movement of air.
Exactly. This is movement of air in a particular direction, or in technically we call it horizontal movement of air. Horizontal movement of air is called as winds. After dealing with winds, we have something called as pressure belts. We have to deal with atmospheric pressure belts, various wind belts of the world. Then we have, or we also call them as planetary winds. Okay. Then we have planetary winds. Okay. Before insulation, I have forgot one more topic here. That is clouds. Does clouds come in atmospheres? Does atmosphere have clouds? Yeah, that is clouds, how the clouds are formed and different types of clouds. Okay, that covers after atmosphere. After pressure belts or planetary winds, we have different air circulation system, winds or air circulation systems. After dealing with them, we have something called as cyclones, anticyclones, and jet streams. Cyclones, anticyclones, and jet streams. How cyclones are developed, what are anticyclones, how are they developed, that all we will see. Cyclones, we have two types of cyclone. One is tropical cyclone, another one is temperate cyclone. We will get the difference between those two. What are they? Then we have various climatic regions of the world. Various climatic regions of the world. It is nothing but your Köppen's classification. Köppen's climate classification. Okay, which is Köppen's climate classification. Apart from this, we have one more Let me write here. Various forms of precipitation. Various forms of precipitation. These are the topics coming under climatology concept. I don't know how much I can finish in this short time period. Let me try to do maximum which I can. Okay, take down this in the same order also, because in future if something is missing, you need to ask your faculties to cover this. Okay. Atmosphere, insulation, clouds, various forms of precipitation, winds, pressure belts or planetary winds, circulations, phenomenon like cyclones, anticyclones, jet streams. Last, climatic regions of the world or Köppen's climate classification. In wind, you take down the subtopic called as local winds. Local winds, which is very much question area for Group C type of exams. Local winds. Okay, all this clear? It is just an overview of climatology topics. Okay, what do you mean by atmosphere? This is the atmosphere, anything which is above the Earth's crust, which is nothing but a blanket of air. Okay, in atmosphere, first we will discuss about its composition. Basic idea, atmosphere is made up of different types of gases. That's all we know. Okay. Among the gases, which is the most abundant gases found in atmosphere? Most abundant atmosphere.
Carbon dioxide.
Carbon dioxide and oxygen. Wrong. Try something. I think we have studied in our high schools, primary school, which is the most abundant element in our atmosphere. No. First and foremost is nitrogen. Abundant element in the atmosphere is nitrogen. Don't take notes. Later on, you can add up along with the percentage. Second one is oxygen. Third one is argon. Carbon dioxide. This order you should do. First one is nitrogen. Second one is oxygen. Third one is argon. Fourth one carbon dioxide. Next we have neon, helium, krypton, and lastly hydrogen. There are other minor elements also like xenon and all. These are less abundant. Okay. This is the major composition of the atmosphere. Apart from this, what all we will find is that like dust. Does atmosphere consist of dust and aerosols? Yes, we have dust and aerosols. Apart from dust, we have one more thing which is very much important, is known as O3 is known as ozone. ground level ozone and stratospheric ozone. In ozone, we have two kinds. One is ground level ozone and the other one is stratospheric ozone. This is the major composition of our atmosphere. Okay. After knowing the composition, let us discuss the structure of atmosphere. How is atmosphere? Is that uniform? Is our atmospheric gases uniformly spread? No. For example, if you are in a trekking, if you have experienced trekking, when you climb certain height, imagine this is an hill station, say it is for about 2000-meter high. If you climb this hill station, if you reach this top, how you will feel? You will feel some pressure to breathe, or you will feel easily as you are breathing now. You will feel something, right? You will feel some difficulty while breathing because the oxygen content here is higher, whereas oxygen content at the top is lower. This is a simple example to show all these gases are not evenly spread in our atmosphere. They have some differences when we move upwards. Okay, these gaseous differences had made atmosphere into different layers. First, just simply you just understand the layers of atmosphere. Later on, you can know what it signifies. Okay, first layer from the ground surface to top, to top 32 kilometers, we have troposphere. What is the significance of troposphere is, it is the sphere where we have life. Apart from that, why troposphere is important in the sense, the density, majority of these gases are present more in troposphere. Later on, the lesser dense they will become. The abundance will decreases with increase in height. First and foremost important layer is troposphere. In troposphere, imagine there is a hill here. This is Earth's crust. Okay, this is Earth's crust. Hill is present here. When you climb the hilltop, how is the temperature? What will you experience? The temperature will be high or low compared to this ground level? Where you started trekking, from there to this hilltop, the temperature you experience will be high or low? Low. Same phenomena in troposphere. When we increase the height, the temperature will decrease. Troposphere, we will experience lower temperature with increase in altitude or height. This term is known as normal. This phenomenon is known as normal lapse rate. What is this phenomena called as? Normal lapse rate. What does normal lapse rate say? Normal lapse rate says with every 165 meters increase in height, temperature decreases by 1 degree Celsius. What does normal lapse rate states is, with every increase of 165 meters height, the temperature will decrease by 1 degree Celsius. Because of this phenomenon, while trekking, we will experience lower temperature at peak levels. Okay. In troposphere, do you find any clouds or not? No clouds. No clouds at all. In troposphere, we have clouds. The rain will come in the troposphere. Okay. After troposphere, we have stratosphere. In troposphere, with increase in height, the temperature what happened? Decreased. Okay, in stratosphere, we have something very important, which is ozone layer. Stratosphere is known for its ozone layer. Stratosphere extends up to 50 kilometers. From ground, here the troposphere will cut. From troposphere, it will extend up to 50 kilometers. In stratosphere, one peculiarity of stratosphere is this ozone layer. It's a function of ozone layer. Yeah, protecting the earth from sun's UV rays. Do you think the ozone layer is a blanket like or a curtain like thing? What is it?
It's a circular.
No, it is not circular at all. Ozone layer is nothing but similar to a room's atmosphere. In this room, we have gaseous molecules. Right? Similarly, in stratosphere, we have more amount of ozone. Ozone is a gaseous molecule which we cannot see through our naked eyes. That gaseous molecule is near this 40 to 50 kilometer height from the Earth's surface. 40 to 50 kilometer height. We have invisible, what we called gaseous component called ozone. Okay, it is not evenly spread. It is thicker near the 50 kilometers. It is thicker near 50 kilometers, whereas it is sparse at the lower levels. Okay, in troposphere, with increasing height, the temperature will decrease. Temperature will increase. In stratosphere, with increase in height, temperature will decrease. Whereas in stratosphere, with increasing altitude, temperature will increase. Temperature. So imagine this is 0. What is the normal room temperature? 23 to 24. Think this is 20 degrees positive. This is minus 20 degree. Here minus 40 degree. Minus 60. Minus 80. Imagine this is temperature scale. This is altitude, height. Okay, this is temperature, this is altitude. With increasing height in troposphere, the temperature will increase. At the most, the highest temperature that can be experienced in troposphere is 0 degrees Celsius. What is the highest temperature can be experienced in troposphere? 0 degrees Celsius. Between troposphere and stratosphere and troposphere, we have a constant layer where much of the temperature difference is not seen. This is called tropopause, where much of the temperature difference with increasing height will not be seen. Such constant layer is called tropopause. In stratosphere, do we find clouds? Do we find clouds in stratosphere? Which one? Take a guess. What do you say? Do we have clouds in the stratosphere? No. We do not see any type of clouds in the stratosphere. The clouds are 0. The clouds in stratosphere are 0, and for that reason, we will have flights. Our flights will fly in this stratosphere. The flights will be, majority flights will be flying at this height because of no cloud region. Okay. After stratosphere, what is the next layer? Good. Mesosphere, also known as middle sphere. Up to 80 kilometers, from 50 to 80 kilometers, we have a sphere called mesosphere. In mesosphere, with increasing altitude, the temperature will decrease. Exactly opposite to stratosphere, with increasing altitude, the temperature in the mesosphere will decrease. Okay. Due to this decrease in temperature, when the comets, first chapter we will read about comets, right? When the comets enter the Earth's atmosphere, it will melt in the mesosphere. Okay, because of extreme low temperature, they will reach up to minus 80 to minus 100 degrees Celsius. For that reason, these comets will melt at the mesospheric zone. Okay, in mesosphere, the temperature, what will happen to the temperature? While increase in height, with increase in height, temperature will decrease. Good. After mesosphere, we have one layer called as Good. It is thermosphere. As the name suggests, in thermosphere, the temperature will be high or low. The temperature, as the name only says, it is thermo. The temperature is high. With increase in altitude, the temperature also increases. Okay. In thermosphere, we have one particular layer called as, do you know? In thermosphere, we have one specific layer with ions present, which is called as ionosphere. In thermosphere, we have a peculiar region with ions. It is called ionosphere. What is the function of ionosphere? Ionosphere will do function like it will reflect the radio waves sent by the earth, ground radio waves. Communication system is happening because of presence of ionosphere. Our TV, our mobile phones, all are working because of this important layer, ionosphere. In this ionosphere, the molecules are present in the form of ions, positive and negative ions. These ions will help to reflect back the radio waves to the ground. Okay, ionosphere is a part of. After thermosphere, we have one more sphere known as exosphere. What happens to the temperature in the exosphere? Will it increase or decrease? Oh, temperature increases. You? What happens to the temperature?
This is when the altitude increases.
Temperature decreases. According to you? Increases. Good. Temperature increase because in exosphere we are nearer to the sun. There is no decreasing in temperature. After thermosphere, the temperature goes on increasing with increase in altitude. This completes the structure of our atmosphere with different layers and the significance of those layers. Have you understood? Are you able to read the troposphere? Temperature will decrease with increase in altitude. In stratosphere, increases up and maximum it can reach up to 0 degree. Increases because from minus 40, minus 30, minus 20, it will reach up to 0. Okay. After that, we have mesosphere. Mesosphere temperature will decrease. Temperature will decrease. After mesosphere, we have thermosphere. Thermosphere temperature will increase, and also in exosphere, temperature will increase. Is the concept clear? Okay. Take down atmosphere. It is the air surrounding the earth. Atmosphere extends up to 1,600 kilometers. 1,600 kilometers above the Earth's surface. Next sentence. 99% of 99% of total mass of atmosphere. 99% of total mass of atmosphere is confined to the height of 32 kilometers, to the height of 32 kilometers from the Earth's surface. Okay. Then composition of atmosphere. Composition of atmosphere. Take down this fact, nitrogen. %78. Oxygen 20%, 20.9. Argon 0.9. Carbon dioxide 0.03, 0.036. Okay. Next onwards, you just take a list. Neon, helium, krypton, hydrogen. krypton, and hydrogen. You should know this order in the same fashion. Okay. Then just know about two of these atmospheric gases which are very important. Don't take notes from this. Okay. Carbon dioxide. Why is carbon dioxide important? What is it? Why it is blooming today? Why it is more in news today? Why is carbon dioxide dealt? You have read many articles in your newspaper. Are you covering current affairs daily? No, not yet. To be frank, you are not yet started. Okay. In newspapers, you will get many articles related to carbon dioxide. Why it is the hero of newspapers?
Many of the things many of the things
No. Not getting consumed. It is not getting consumed, but it is getting emitted. Many things will emit carbon dioxide when they are burned. Because of that human emission or anthropogenic emission, it is in news and it has become the hero of our newspaper. Okay. Because of more and more emissions from our vehicles, industries, be it anything, any burning of fossil fuels, anything, the carbon dioxide we emit more. Because of more and more carbon dioxide emission, we have the phenomenon called greenhouse. Due to this effect, the carbon dioxide is coming more in use. Okay, greenhouse effect. What is this greenhouse effect? What does it say? What do you mean by greenhouse effect? Sorry, this is completely different topic. There is no correlation with the ozone. Okay, that which you spoke is something nearer to ozone depletion. It has no correlation with greenhouse effect. What is greenhouse effect in the sense? From sun, we have incoming solar radiation entering the Earth's atmosphere. Okay, this incoming solar radiation get absorbed by many atmospheric molecules, many atmospheric gaseous molecules. For example, carbon dioxide, methane, water vapor, other things, sulfur hexafluoride, chlorofluorides. Like this, many atmospheric gaseous molecule will absorb this incoming solar radiation. Okay, this gaseous molecules gets heated up due to absorption of incoming solar radiation. They will get heated up and they will conserve that energy for some time. They will keep the energy with themselves for some time. After some time, they will emit the energy radiation back. This radiation is called terrestrial radiation because it is happening in the Earth's atmosphere. Terrestrial is nothing but Earth layer. Okay. This trapped energy by these molecules is called as warming of Earth. This is called as global warming. The energy which is trapped inside such molecules present in the atmosphere is called as global warming. It will increases the temperature of the Earth. That phenomenon is called as global warming. And the effect is called greenhouse effect. And these gases are called greenhouse gases. What will they do? They will absorb the energy and they will not radiate them easily. They will absorb the energy and heats up the Earth. This phenomenon is called as greenhouse effect. Okay. In environment chapters, you will discuss in detail what are greenhouse gases, how many greenhouse gases are important, and what is their greenhouse potential. Okay. Then you have ozone. Ozone is found mainly between 10 to 50 kilometers. That too, they are found abundantly between 40 to 50 kilometers. Okay. Have you heard about ozone hole? Ozone hole. What is ozone hole? Yeah, in the places where the ozone layer is getting depleted is called ozone hole. Then we have dust particles. Okay, link this. Then take down atmosphere structure. Structure of the atmosphere. Atmosphere divided into 5 layers. Structure of the atmosphere, it has 5 layers, namely in diagram you can represent that. Just do you want me to write again or you will copy from here? You will copy? Okay. Take down this diagram. Here you in y-axis altitude. In x-axis you just mark it as temperature. Temperature in y-axis mark it as altitude. Troposphere you just mark as 8 to 18 kilometers. Sometimes near poles it is troposphere is only 8 kilometers. In the equator it is 18 kilometers. Okay. Here in the y-axis take down 8 to 18 kilometers and write it as troposphere. You should also mention this. So leave some gap. You should mention this temperature and you should take this graph also. Where? Okay. After troposphere, you have stratosphere up to 50 kilometers. Stratosphere. After stratosphere, you have mesosphere up to 80 kilometers. After mesosphere, you have thermosphere up to 400 kilometers. Lastly, you have exosphere. From above 400 is your exosphere. These kilometers are also important. You just take this temperatures 0, plus 20, minus 20, minus 40, minus 60, minus 80, minus 100. From 22, draw up to minus 40 or minus 60 in troposphere. From 0 to minus 60. In stratosphere, from minus 60 to 0. In mesosphere, from 0 to till minus 80. From 80 to be increasing till exosphere, it will go on increase. And Give the synonym troposphere. First point, it is 18 kilometer near equator and 8 kilometer on the poles. Troposphere, it is lowermost layer. It is 18 kilometer near the equator and 8 kilometer near the poles. Why such difference is seen? ಯಾಕೆ ಡಿಫ್ರೆನ್ಸ್ ನೋಡ್ತಿದೀವಿ? ಯಾಕೆ 18 ಕಿಲೋಮೀಟರ್ ಒಂದ್ ಹತ್ರ ಹೇಳ್ತಿದೀವಿ, ಯಾಕೆ 8 ಕಿಲೋಮೀಟರ್ ಒಂದ್ ಹತ್ರ ಹೇಳ್ತಿದೀವಿ? Why is this difference? Here we have equator. Here we have poles, right? In North Pole and South Pole, the thickness of troposphere is only 8 kilometer, whereas on equator we have thickness of 18 kilometer. Why is this so? Mid portion, so that is not the reason. Sun's vertical rays always fall on the equator. Sun rays fall on equator, which will makes the molecules get heated up. When something is heated up, will it move faster or slower? When something is heated, will it move faster? The molecules will spread or not? It will spread, right? The molecules will spread because of sun's heat and it is extended up to 18 kilometers. Whereas at poles, there is a low temperature, the molecules will get shrinks and it is only for about 8 kilometers. Have you understood the reason why it is 18 and 8? Okay. Take down. Troposphere is 18 kilometers near equator and 8 kilometers in the poles. All kinds of weather phenomena happens in troposphere. All kinds of weather activities happens in troposphere. We are getting good response in YouTube. How is your response? Give me some feedback. How is the class? In one word, in one sentence, at least in one sentence. Huh? It's interesting. How do you feel? Say something different. Mark your presence. Sorry, I can't hear you. It's knowledgeable. You are getting what I'm saying. Very good. Okay, all kinds of weather phenomena happens in the troposphere. For example, cloud formation, precipitation. Okay, all kinds of weather events happening in troposphere. Next important thing is the temperature decreases in this troposphere only. Temperature decreases with increase in altitude or height. Temperature decreases with increase in altitude or height. Temperature decreases with increase in altitude or height. This phenomenon is known as normal lapse rate, which is very much important to know. Normal lapse rate. This phenomenon is called as normal lapse rate. Okay. Under that, you just write down like this: 165 meters increase in height, 1 degree Celsius temperature decreases. You just, to reduce the words, take down in a formula format: 165 meters increase in height, 1 degree Celsius temperature decreases. Okay. Then we have tropopoles. The next is tropopause. It is a layer separating troposphere and stratosphere. Just take down tropopause, layer separating stratosphere and troposphere. Second important layer, stratosphere. Stratosphere up to height 50 kilometer, above troposphere up to 50 kilometer. Known for ozone layer. Known for ozone layer. Temperature increases. Temperature increases with increase in height. Increase in height. Weather related activities are not present. Weather related activities are not present. Not present. Hence, it is ideal for movement of flights or aircraft. Hence, it is ideal for movement of flights or aircraft. Then you have, in that, under that only you have stratopause. Stratopause is a layer between stratosphere and mesosphere. Just mention stratopause. You will get to know what it is. Stratopause. Next one, mesosphere. Third layer, it extends up to height of 80 kilometer. Up to 80 kilometer. Temperature decreases. Temperature decreases with increase in height. And it reaches minus 100 degrees Celsius. Reaches minus 100 degrees Celsius at 80 kilometer. Then meteors fall in this region. Because of low temperature, they will burn. They disappear. Actually, they will not burn, they will disappear in this layer. Meteors will disappear in this. Okay. Then you have thermosphere between 80 to 400 kilometers. Thermosphere 80 to 400 kilometers. It contains electrically charged particles. It contains electrically charged particles known as ions in ionosphere. Charged particles known as ions in ionosphere. Okay. This is important. Ionosphere. In that you just put an arrow and write important for radio signal transmission. Radio signal transmission. In thermosphere, temperature increases. Temperature increases. Means increase in heights. Then you have exosphere, which is the last sphere. Exosphere above 400 kilometer. Do you have abundance of molecules in exosphere or no? Do you have abundance of molecules, air molecules in the exosphere, or they will be at sparse? They will be at far apart. There are less molecules in exospheres. Exosphere is known only for heating. Gases are very sparse in exosphere. Temperature increases. Okay, getting late. Oh, then we have a new concept called as insolation. You just hear and take down the notes then and there. If something is important, you just write along with it. Okay. Insolation, as I said already, insolation is the incoming solar radiation. In this important thing, I just only go for important thing. Okay, let them cover in each budget of the earth. Just understand what it is and just take this only this much is enough. Okay. Incoming solar radiation. What is heat budget? First understand what is budget. Anywhere if you find the word budget, till economics is not completed, right? Economics not even touched. Okay, anywhere if you find the word budget, in the sense it is like what comes in. For example, budget is like a bogette. It was derived from a bogette. What comes in and what goes out. It is nothing but auditing. It is nothing but auditing what comes in and what goes out of your pocket. Like that, in the similar fashion, heat budget. In terms of sun's radiation, we are talking in this chapter. Okay, heat budget. Imagine this total amount of sunrise which the Earth's atmosphere receives is 100. At the top of exosphere, total amount of sun rays received by the Earth's topmost exosphere is 100. Okay. Before entering the Earth's atmosphere, it will get reflected. Why it is getting reflected? What may be the reason for reflection? It won't get absorbed easily. It will get reflected. Why is so? Why it is reflected back to the atmosphere?
Because they absorb the radiation and after some time they
emit the radiation. That is greenhouse effect. After some time, they will emit. That is greenhouse effect. Why it is reflected? Because few molecules in the atmosphere which are white in color, light in color. Example, clouds. Clouds. Such clouds will not get absorb the energy. For example, if you see, if we wear black kind of dress in the hot summers, we will experience more heat. If you wear white cotton clothes in the summer, the light will get more reflected and your body will get cooled. In the similar fashion, because of color of the cloud, which is ash white color or gray white color, it will reflect more amount of energy. Among incoming 100%, such reflections will be 35%. How much percent it will get reflected? 35%. That is 100 minus 35, how much we have? 75. No, we just have 65%. 100 minus 35. Such reflection. This reflected rays is called as albedo. Albedo is nothing but reflected light. Okay. Albedo is nothing but reflected light. Such reflection, total reflection is 35% from the Earth. Other remaining amount will get absorbed by the Earth's atmosphere. Absorption in the sense they will absorb and hold that energy for some times. Okay. Among this 35%, 51% will be absorbed, 65% only, 51% will be absorbed by the earth surface. In the sense, crust will absorb 51%, and after some times it will radiate 34% back into the atmosphere. How this radiation happens? Because of greenhouse effect. Because of greenhouse effect, which I explained previously, carbon dioxide, water molecules, methane molecules, they will absorb this energy and they will emit back in the form of something not written, in the form of terrestrial radiation. Okay, 34% is get emitted from the terrestrial radiation. Okay, then total amount absorbed by the earth is 51%. 51% is the amount of energy absorbed by the earth. After 34%, remaining 14% will be absorbed by atmospheric clouds. 34% are absorbed by atmospheric gases like greenhouse gases, whereas 14% get absorbed by the clouds, atmospheric clouds. Together, they will form the same amount of energy which is absorbed by the Earth's atmosphere. The incoming and the outgoing radiations are same. That is, the concept is known as heat budget of the Earth. Clear? What is heat budget? The incoming radiation and the outgoing radiations are same. There is no net gain or loss in the radiation. In detail, how much clouds will absorb, how much the other things like surface of the earth will absorb, you will get in your advanced classes. As per today, you just learn the incoming solar radiation coming in and going out. Okay. Just if you want, you just make some important points like incoming solar radiation is 100%, total reflected is 35%, minus 35. Earth absorbs 51%. Radiation absorbed by the atmosphere is 34%. Okay. Then in that also you have the concepts like convection, advection, conduction, which will be covered in your advanced classes. Okay. Then you have something important called clouds. What do you mean by clouds? Huh? Clouds made up of tiny water droplets. When they condensed in the upper atmosphere, they will form a dense clouds. Okay. In this chapter, let us learn different types of clouds. Formation of clouds from childhood days, we have learned water cycle. In the water cycle, how water evaporates, condenses and forms clouds, we have learned. In this chapter, our focus is mainly types of clouds. In types of clouds, we have majorly three kinds of clouds. First, just understand it in layman terms. There are three major kinds of clouds. One is cumulus clouds, second one is stratus clouds, third one is cirrus clouds. You just learn how they look. Okay, this is the main features. Just understand. Later down you can take the notes. Cumulus clouds are like a cotton ball. These are massive, like a cotton ball. Have you seen such type of clouds? During our paintings, we used to write majority of cumulus clouds. In our drawing books, we have written these clouds. These are nothing but cottony balls. Then we have stratus clouds. Stratus clouds are like this. Something which is stratified, something like layers, we have stratus clouds, which when we see from far up, they look like layers stacked one upon the other. Then we have cirrus clouds. Cirrus clouds are more or less like a fibrous clouds. They are visible like a thin fibrous lines. Okay, these are cirrus clouds. Then you just imagine which cloud could be nearer to the earth, which cloud could be far away from the earth. Just think, use a logic and say. Cirrus are far from the earth, whereas are near to the earth. According to you, same. Cirrus are far from the earth, whereas cumulus are near to the earth. Exactly, you both are right. Cirrus are far from the earth. Then we have types based on altitude. Altitude is nothing but height. Types based on altitude. We have three major kinds. First one is low clouds, which are less than 2000 meters. Low clouds are the one which are from Earth's surface up to 2000 meters. Then we have middle clouds, which are from 2000 to 6000 kilometers or 6000 meters. Okay. Then we have high clouds, which are above 6000 meters. These are the three kinds of classification based on altitude. Among that, we have subtypes. Okay. In high clouds or in low clouds, we will see something like the name has cumulus word in them. Okay. We have another one type of cloud, which is high altitude clouds, or one more familiar name is vertically developed clouds. The fourth kind is vertically developed cloud. What are vertically developed clouds? These are very high in height such that they cannot be classified as mid cloud, high cloud or low cloud. They are very much high in their development. They are such a massive clouds. These are massive clouds. They have very huge development in their height. Okay. These are the four major types of clouds. Without knowing their photo, we cannot imagine them. Just go through this photo. Okay. Just observe now. These are high clouds. First classification is high clouds, which are above 6000 meters. Okay. High clouds. In this high clouds, this is cirrus. We have sub-classification within high clouds. First one is cirrus clouds. How are cirrus clouds looking? They are feather-like. Fibrous, feathery-like. In this, you can see the cirrus cloud here is a feather, tiny feather-like substance. Okay. Then we have cirrostratus. Cirrostratus is also a thin cloud. Cirrostratus is a thin cloud which has the combination of features of cirrus clouds and stratus clouds. Our stratus clouds? Stratus clouds are stratified, whereas cirrus clouds are feather-like. Cirrostratus is a second type of high cloud, which is seen as a halo around the sun. When sun is shining in the afternoon, morning to afternoon, the cirrus clouds forms halo around the sun because they are thin. They are visible like halo around the sun. Then third type, it is actually cut here. It is known as cirrocumulus. What is the third kind of high cloud? Cirrocumulus. You can see, if it is visible, you can see something like a small cotton puff like substance is cirrocumulus. This is the third type of high cloud. Okay. Then we have middle cloud. Second one is middle clouds. Middle clouds, we can identify middle clouds with the name, they starts with alto. Middle clouds have the name alto. Okay. In middle clouds, we have two types. One is altostratus. This is altostratus. Similar to, they appear to like stratus clouds, but they are in the middle layer. Okay. Then we have altocumulus. Second important one is altocumulus, which are similar to cumulus clouds, but these are not that much heavy as cumulus clouds. They are slightly sparse or staggered. Okay. Then third type is low clouds, which are very near to the ground level. Among low clouds, we have, what is this cloud called as? Cumulus. First one is cumulus. Then we have stratus. Combination of two, stratocumulus. Oh, this is all the three types of low clouds. And the fourth major type is vertically developed clouds. This is what I said. These are not classified as particularly low cloud or high cloud. These are vertically developed clouds. Vertically developed clouds has huge height. These are cumulonimbus clouds. There are vertically developed clouds. In this, we have two kinds. One is cumulonimbus clouds and the one is nimbostratus clouds. Nimbostratus clouds. These are giant. These are clouds are giant clouds. They cause heavy rainfall and also heavy thunderstorms and lightning. These clouds, vertically developed clouds, brings heavy rain. They bring heavy rain and also heavy thunderstorms and lightning. After completion of class, when you go out of the class, you just observe the sky. Observe the sky and notices which all type of clouds can be seen. You can find these type of clouds. In your area, you can find majority of cirrus clouds and also you can find during rainy times. Now it is raining heavy in Kalaburagi, right? Now, in the sense, in recent months, you have experienced many floods, devastation, farmland devastations here. During that times, you have cumulus clouds and cumulonimbus clouds, like this type of vertical developed clouds. In Kannada, we call them as karmodagalu. Have you heard of this word, karmodagalu? Karmoda is nothing but the gray development, gray color, big clouds which cause heavy rain. Okay. These are different types of clouds. Take down high clouds. High clouds. These are above 600 meters. Above 600 meters. These are known as cirrus clouds. Done. No, while dictating I said, okay. While doing lesson I said 6,000, right? Okay. 6,000 meters. I said 600 now. Okay, sorry. These are known as cirrus clouds. They are usually thin. Usually very thin, feather-like. Do you think they bring rainfall? No, they are not rain-bearing clouds. They do not produce rain. They are thin, feather-like, do not produce rain. In that, you just make a list types of high clouds. Cirrus, one is cirrus, cirrostratus, and cirrocumulus. Just make the list. Apart from that, you know how they will appear, what is the color, how they will appear, and will they bring rain? They won't bring rain. Cirrus, cirrostratus, and cirrocumulus. Okay, then we have middle clouds. In middle clouds, they form between 2000 to 6000 meters. They are found between 2000 to 6000 meters. These are known as alto clouds. Middle clouds have the name called as alto clouds. Will they produce rain? The middle clouds. Will they produce rain? Yeah. They will produce a little bit of drizzling. Not heavy downpour, they will drizzle. Drizzling rains. They produce rains. They produce rains in the form of drizzle, or snow. Types of middle clouds: alto, stratus, alto, cumulus. Stratus is like a sheet like, whereas cumulus is a cotton like. Then we have low clouds. They lie below 2000 meters. Low clouds, they lie below 2000 meters. These are known as stratus clouds. Stratus clouds. They appear dense. Dark in color, and bring heavy rains. Brings rain. Types: stratocumulus. In that stripe, stratus and nimbostratus. Then last type we have vertically developed clouds. Great vertical extent clouds. They are also called as storm clouds. They are also called as storm clouds. They bring heavy rains. They bring heavy rainfall along with lightning and thunderstorms. In that types, cumulus and cumulonimbus. Cumulus and cumulonimbus, vertically extend clouds. By looking at this photo, any one of you can summarize high cloud, low cloud, and middle clouds. Anyone? High clouds. Take high clouds and say something about high clouds.
They are like feathery structure. And once we have feathery structure, they don't produce rain. The types of high clouds are cumulus, stratus, and cirrus.
Good. Low clouds. What do you know about low clouds?
Low clouds are like the shape of cloud structures.
Height. Where are we getting low clouds? Below? Below 2000 meters. Types of low clouds? You can see by looking at this photo or your notes. Type of low clouds. Cirrus is not a low cloud. Cumulus, good. Good. Strato, cumulus. Okay. Then we have other two, vertically developed and middle clouds. Okay, clear? After this, we have precipitation and various forms of precipitation. In detail, we are not going into the precipitation. You know what is precipitation? What is precipitation?
Clouds and heavy, they produce rainfall, snow.
This is
Falling of the water or snow.
the falling of water is nothing but atmospheric moisture on the surface of the earth is called precipitation. Why it falls to the earth? Why not it escapes into the atmosphere? Why it falls to the ground? Because of Earth's gravity. Earth have some force called gravity which will attract the precipitation to fall on the ground. There are 5 major types of precipitation. In detail, you will learn about this in your advanced classes. There are 3 major kinds. One on-ground precipitation, near-ground precipitation, one upper atmospheric precipitation. Okay, in this, all these types you will learn in your advanced classes. As of now, just know the major forms of precipitation. One is rainfall. In rainfall, you will get molecules of water. Then another one is snow. In snow, you will get water in the form of ice crystals. Then you have hailstorms. What is hail?
When it's rain with it,
Yeah, the pieces of ice cubes will fall on the earth. That is known as hailstorm. Then we have sleet. What is sleet?
rain with snow.
Rain with snow, and also we will have some amount of water, moisture content, and also snow. Together they will form sleet. Then we have drizzle. What is drizzle? Drizzling. What is drizzling? Yeah, these are smaller water molecules. These are smaller water dry drops which are less than 0.5 mm in size. These are various kinds of precipitation. Okay, then types of rainfall, just I will say what it is. In detail, you will learn later. Okay, first type is convectional rainfall or convective rainfall. What is convectional rainfall? In the sense, convectional rainfall occurs when sun radiation heats up any water body, and these water molecules will get evaporated due to heat produced by the sun. This is known as convectional rainfall. They will rise away from the earth and they will form clouds. This is known as convectional rainfall. It is a normal phenomenon. It happens everywhere temperature is high. For example, in the equatorial places, we will have convection rainfall. Then we have orographic rainfall. Second major type is orographic rainfall. In orographic rainfall, we need something like a landform, which is a tall landform, nothing but mountains or hills. In this, what happens? The clouds are formed in the upper atmosphere. These clouds, which are heavy, when they are obstructed or hit by mountains, they will bring rains. Such type of rainfall is called as orographic rainfall. Then third one major type is cyclonic precipitation or cyclonic rainfall. Cyclonic rainfall. In this, how cyclones develop? Can I go in detail for cyclones? You know what are cyclones? No. Cyclones? Okay. I will discuss at the end of the chapter. It needs more time. Okay. Cyclonic precipitation, for your understanding, just understand. There are ocean. In ocean, we have ample amount of moisture. This moisture, when we have low temperature, it will form clouds and it will bring rain. In detail, I will explain what are cyclones in the later chapters. For this understanding, you just understand in oceans, there will be some places where we have low pressure systems with high temperature. At such systems will develop high clouds and bring heavy rains. Okay. After pressure builds, you will get to know about pressure and temperature and its correlation. Then you can understand cyclones. Just write down the ending. Types of rainfall. Types of precipitation. Just marks the heading. That's enough. Rainfall. Snow. Hail. Heat. Drizzle. There's something missing here, that is fog, mist, dew. Just continue the list. Fog, mist, dew. These are also kinds of precipitation. Then you take the types of rainfall. First one, convectional rainfall. Second one, orographic rainfall. Third one, cyclonic rainfall. Then next concept, you have winds. Take down atmospheric winds. What is the meaning of wind? Wind is horizontal movement of air. Wind is something. Air is something which we can feel, right? Air is something which we can feel, whereas wind is even more, we can feel the wind because it will move in certain direction. Its movement will make us sense that. Okay, when something, if you stand near this AC, we can see the breeze coming. This is wind because it is flowing in a certain direction towards us. This is called as wind. The horizontal movement of air in particular direction. Horizontal movement of air in a particular direction is called as wind. Do you want break? Are you exhausted? Okay, let's take 2 minutes break. Just fresh up yourself. Let's take 2 minutes of break and we continue. Okay. It's actually draining when we speak for hours together without a break. Human brain has a limited capacity. Just 2 minutes, I will start. Can I start? Okay, starting with wind. How are winds formed? Winds are nothing but the movement of air horizontally. When they move vertically, we have convection, conduction, convection, advection. Okay, winds. Another name for wind is advection. One more name for wind is advection. Okay, wind is nothing but horizontal movement of air. After understanding the wind, you should know something which is fundamental: pressure. Do you know what is pressure? In physics classes, they told you about pressure. What is pressure? Good. Pressure is like a force applied to the certain object. Similarly, we have atmospheric pressure. For our discussion, we just need atmospheric pressure. Try to understand in wordings, you can look upon that later. Atmospheric pressure is nothing but this is earth crust. On earth crust, we have atmospheric column. Okay. For our study, we will take a unit area of this unit area of the earth crust. On this unit area, the air column present above will exert some amount of force. The air column will exert some amount of force upon this one unit area. The amount of force exerted by this air column, entire air column on a unit of area is called pressure. This, because it is exerted by the atmosphere, it is called as atmospheric pressure. Have you understood what is atmospheric pressure? Pressure in simple terms, it is amount of pressure or amount of force exerted by the entire atmospheric column of gases on unit area on Earth. Okay. This atmospheric pressure is measured by a device. What is the device which measures pressure? Do you heard about that? What is the pressure which measures? What is the device which measures pressure? Have you heard of that? It is nothing but barometer. Barometer is a device which measures pressure. Okay. This barometer is used to measure the pressure. Okay. After this, you just understand another one more simple concept, a correlation between temperature and pressure. There is a simple correlation between temperature and pressure. What is this correlation? Just first for your understanding, later on you can tell me what is the correlation. Okay. Imagine two areas. One is Rajasthan, which is very much dry. Then which is wettest place in India? Wettest. Mizoram, near to the Mizoram. You are very close to that. Mawsynram. Mawsynram is in Meghalaya. Okay. In Meghalaya, Mawsynram, Cherrapunji is the wettest place in India. Imagine you are in Rajasthan. The air column in Rajasthan exerting some amount of pressure on the place. Unit area of study is just take 1 meter square. 1 meter square in Rajasthan. The amount of pressure exerted by the air column in Rajasthan's city of our study, will it be more or less? Okay, in simple terms, the temperature in Rajasthan is high or low? Temperature is very high. When temperature is very high, do you think molecules are near to one another or they're far apart from one another? When the temperature is very high, the air molecules, will they be near to one another or will they be at far distances? They will be at some distances, and the molecular density is high or low. Density is nothing but the distance between the molecules. They are closer or far? When they are far, the amount of force exerted by such molecules is high or low? The force exerted by such far molecules will be low. Okay. The force exerted is very low. In similarly, Meghalaya or your Mussoorie, where the temperature is low. Temperature is comparatively low when it compared to Rajasthan. Here, how will be the molecule? Will they are close or will they move apart? They are very much closer. Density is high. Density is high. They are very much close. When they are very much closer, will they exert high amount of force or low? High amount of. They will exert enormous amount of force on this steady area. So here we experience that force is nothing but pressure, right? we experience what pressure? High pressure or low pressure? Yeah, experiencing high pressure. This is the correlation between pressure and temperature. When temperature is high, pressure will be low. When temperature is low, pressure will be high. So that we can state temperature is inversely proportional to pressure, or pressure is inversely proportional to temperature. From now on, if I ask in certain area, we will experiencing high temperature, what will you say? That's okay, na? That's it. For now on, you have to say temperature and pressure are inversely proportional. This is the fundamental basic idea. Okay. Let us now learn world pressure belts. Pressure belts of world. What are pressure belts of world? These are a belt formed due to similar pressure. Okay, these are the belts formed due to points joining the similar pressure. For example, for layman understanding, think this is India. In India, we have some places with same pressure. Some places with same pressure. For example, here we have Mumbai. Mumbai is a coastal city, right? Mumbai, coastal city. Then in the same latitude, we have some other city. Think that Bhubaneswar. Bhubaneswar. Will they experience same amount of temperature? Because they are on the same latitude. Okay, latitude and longitude chapter not covered for you, right? This is what happens when they split the course into foundational and advanced batches. Some fundamental things which you have to know before understanding these advanced chapters like pressure belts. Okay. For your understanding, I will say these are on same latitude. Latitude in the sense they experience same temperature. When they experience same temperature, both have access to moisture content in the sea. They will experience similar amount of pressure. They have similar atmospheric pressure. When the line join the places having similar atmospheric pressure, this such line is called isobars. Okay. Isobar is a line joining places with same, not temperature, same pressure. Okay. If they have same temperature, it is called isotherms. Okay. Clear? What are isotherms? These are lines joining the places of same temperature. What are isobars? These are lines joining the places of same pressure. Okay. Then you are good to go now. Let us now understand pressure belts of the world. This is your globe. I'm sorry, longitudes and latitudes are very much important. These are not in your syllabus as per now. Okay, we have not dealt with that. As for your understanding, I will say few important latitudes to you. First, learn them. First is latitude is nothing but your horizontal line, whereas longitude is nothing but your vertical lines. Okay. First and foremost important latitude is equator. Equator is a 0-degree latitude which cuts the earth into exact equal hemisphere, two equal hemispheres. Okay. After that, we have 23.5, which is very much important. 23.5 degree north and degree south. Okay. 23.5 degree north is called as Tropic of Cancer, and this is called as Tropic of Capricorn. After this, we have 66.5 degree north and 66.5 degree south. Above the part, above 66.5 degree north is called as Arctic Circle, and the below is called as Antarctic Circle. And at 90 degree north and 90 degrees south, we have North Pole and South. These are the major latitudes we need to know. After knowing them, you just tell me sun rays. Imagine sun is here. Imagine sun is here. Which region, which latitude will get highest amount of heat? Okay, good. This entire range is called as tropical region. Tropical region will get highest amount of temperature, highest amount of sun rays. This region which receives high temperature is called as tropical region. This entire zone is called as tropical zone. Okay. After that, we have slant rays of sun's slant rays. Not here we have perpendicular rays, direct rays falling on these tropics, whereas 23.5 degree north, above that and below 23.5 degrees south, we have slant rays of sun, which is not that much heating as compared to tropics. And these regions, these dotted regions, we call them as subtropical region. Subtropical regions. Above that, about 66.5 degree up to 90 degree, we have regions which receives very low amount of sun rays, and these are called as temperate regions. Okay, temperate regions. Near 90 degree north and 90 degree south, we have regions. These regions are called as polar regions. Clear? Okay, what are the major regions? One is tropical region, then subtropical region, temperate region, and polar region. This is the basic overview. Now let us understand the pressure belt. This is 0 degree equator. At equator, will you receive high amount of temperature or low amount of temperature? Temperature will be high or low? High. When temperature is high, what the pressure will be? Pressure will be low. At equator, we have a pressure belt called low pressure belt, or this is also termed as equatorial low. Good. Equatorial low. That low signifies low pressure belt. Okay. Low signifies what? Low pressure belt. Above equator, we have which region? Okay. For this pressure belts, we will round it up to 30 degree. Near 30 degree, which kind of climate we will see? Whether it is tropic or subtropic? Exactly, subtropical regions. Will you get more amount of energy or less amount of energy there? Heat. Huh? Compared to equator, we will get less amount of heat. Then when temperature is comparatively low, will the pressure high or low? Pressure will be high. This pressure belt is called as subtropical high pressure belt. Okay, this pressure belt is called subtropical high. In both the hemispheres, the same name, say subtropical high pressure belt. Next important latitude we are studying is 60 degree north and 60 degree south. The temperature will be high or low? Compared to this, the temperature is low. Okay, before moving to 60 degree, we have famous 90 degree north and 90 degrees south. In 90 degree at polar regions, will you experience higher temperature or low temperature? Lowest temperature we will see in polar regions. When temperature is low, what will be the pressure? Yeah, these are called as polar high. These pressure belts near polar region are called as polar high. The pressure belt here. Okay. Compared to this region, the temperature in 60 degree north will be high or low. Compared to polar regions, the temperature will be high or low? Compared to polar regions, we have high skews. Okay. Compared to polar regions, we have temperature which is high. When temperature is high, pressure will be low. Hence, we get subtropical low pressure belt. Don't mug up these belts. Just understand what is the temperature there and just name them. Okay. First one is equatorial low. Then we have subtropical high. After that, subtropical low, polar high. These are same in both the hemisphere. These are known as permanent pressure belts of the world. These are permanent pressure belts because the sun rays will occur in same fashion. They won't change much. The equator region gets sunlight every day equally. 12 hours of sunlight we will get in the equatorial region, whereas polar regions get slant rays of sun. Very low amount of temperature will be there. This is known as major pressure belts of the world. Okay. Now let us understand something. This equatorial low pressure belt is also called as the equatorial low pressure belt. There is another name for equatorial low pressure belt, that is doldrum, because of high temperature here, the air molecules will get evaporated. They will move upwards. The air molecules will move upwards. Always they will move upwards. For example, think this green carpet here is an equatorial region. We are getting high amount of sun rays in this region. What will happen to the molecules? They will evaporate faster and faster. They will move like this. They will move faster and faster, and for that they will clear a vacuum here. A cavity will be created in the ground surface. Hence, it is called as doldrum, which looks like a drum. It is dold. Okay, which is empty drum. Its name, just for your remembrance, I am telling like that. Okay, it is not empty over there. For your remembering, it is doldrums. Okay. Then we have 30 degree north and 30 degree south. We have given this pressure belts a name called as horse latitudes. Horse latitudes. Okay, just learn this. Okay, I will tell why it is called as horse latitude in the later thing. Okay, now the pressure belts are clear. All the pressure belts are understood. Okay. It's already 110. Okay. Take down this. Barometer is the unit. Before, have you written what is air pressure? Definition of air pressure? No? Okay, right. Air pressure? Yeah, atmospheric pressure, same. Air pressure is defined as total weight of mass of column. Total weight of mass of column of air above a unit area at sea level. It is measured by barometer. After that, pressure belts of the world. Give the heading, pressure belts of the world. Just take down these names. Tomorrow we will cover major planetary winds of the world. Okay. Just take down name for today's class. Equatorial pressure belt. Tomorrow let's continue from here. Equatorial pressure belt, subtropical high pressure belt. Have you written? Good. Yesterday, did I give any homework? What I said?
States where they can plateaus.
Yeah. How many states?
Maharashtra and Pradesh.
Good.
Maharashtra and Pradesh, Tamil Nadu, Kerala. But some parts of
Madhya Pradesh. Good. It is the previous year question, so I just wanted you to know how many states the Deccan Plate. Okay, discontinuities also, name them in an order. Now, before we have one more discontinuity, corner discontinuity. Few textbooks will miss that. Okay, corner. Okay.
That's question mental.
Good.
Then
Discontinuity.
Boundary between mental and four.
No.
Then one discontinuity between four and
Outer core and inner core. These are the main things. So one more missing is corner discontinuity. Okay. Corner. Anything else? Any doubt you have till today's class? It is a big chapter. We can continue the pressure belts and planetary winds. See, it is like huge chapter. These planetary winds needs your understanding. These planetary winds, how they will flow, needs very much of your interest and patience. You need to understand these cells. What are these cells? How these pressure belts will work. Okay. This is not possible to cover in 5 minutes. We just have crossed the limit. No, it's already 1:12. Tomorrow I will continue these winds. Then we have local winds. Local winds, something like land breeze, sea breeze, mountain breeze. Okay. And also we have some of the localized winds like Chinook, Lu. These are the local winds which we cover tomorrow. After this, we have climate classification. Cyclones. Cyclones is very much important for your exam perspective. Cyclones we will deal tomorrow. I will ask the faculty what can we do. Tomorrow we have oceanography. At least 1.5 hours I need for this only. I will ask the faculty what can I do, or will I end here? Will another faculty continue from here, the climatology? I don't know. I will ask them and let you know. Okay. After this, you have temperate cyclones, anticyclones. Okay. Then you have climatic classification of coupons. Okay, just try to solve these questions. A few questions will be covered. Actually, first one, you answer the first one. Good. It's in troposphere. Vishwanath. Which of the following layer of the atmosphere marks the radio communication possible? Thermosphere? Thermosphere is the answer. In thermosphere, we have one specific layer called as ionosphere, where ions are present. That layer is the answer, ionosphere. If this is not given in the option, you have to go for thermosphere. If the option is present ionosphere, you have to mark it as ionosphere of the atmosphere, whether it is tropo, thermo, strato and mesosphere, where the temperature increases. Troposphere temperature decreases. It is normal lapse rate. Among the given option, where will you see the highest temperature? It is in thermosphere. As the name signifies, thermosphere, thermo. Thermo means hot layer. Okay, this is not covered for you. Okay, let's end the session now. Do you have any doubts? No? Anything need to be asked? Any subject for your preparation? You will find something tomorrow. Thank you.